This is a really brief tutorial about the One Data Model activity and the SDF format that is being created there. Michael Costa had a very nice tutorial about this at the Singapore IATF, or actually at the workshop we had ahead of that. I'm not going to try to redo his work there, but I'm going to take a slightly higher level view and try to explain what are the components and cogs and gears and how do they actually fit into each other. So just as a reminder, why is it useful to do this? Of course, it's always nice to have common standards, but really the motivation here is that we have a number of ecosystem-specific standards development organizations in the Internet of Things, and each ecosystem has developed their own data models and their own way to document them. And it turns out applications really have to talk to things, to devices from multiple ecosystems. So there is no chance that a single ecosystem can supply all the devices that may be needed in a less than trivial IoT application. So applications need to talk to all those devices from all those ecosystems, or from many of these ecosystems. And while building protocol translators is possible, I mean, it's not easy, it's possible, it's actually even harder to translate the hundreds of data models that we have out there for the different devices. And actually, nobody is really making money for having a better data model than the other ecosystem. So it's not really something where people compete. So at some point, people from different SDOs, standards development organizations, noticed this and created a liaison group, which is an informal group of people from these different SDOs who talk to each other. And the idea is to bring together these hundreds of ecosystem-specific data models, express them in a common format, and then actually work on merging and harmonizing. It's really hard to merge data models that are in a completely different forms. But once you have expressed them in a common format, you actually see, oh, this is redundant, and our model is actually missing that part, and let's add that, and so on. So this is really the harmonization process, and that is just starting. I think that right now there is a single model where that actually has worked, but that's really the main job here, to look at data models and look where there is potential for coming up with common models. So the whole thing is done in the open. The data models will be available for all. It's a BSD license behind them, so it's completely open source, no strings attached license. And actually, even though the liaison group still is a group of SDOs which are mostly operating under non-disclosure agreements, the actual harmonization work is happening in the open. So you can go to the GitHub repository One Data Model and find things there. Now, I have stressed the need for a common format, and that's what I'm going to focus on for the next 10 slides. So in order to be able to harmonize data models, we need to be able to express them in a common format, and that's SDF. So SDF stands for Simple Definition Format. Usually all standards that start out with the word simple in their name at some point have to lose that word. Well, there is a certain hope that we actually can have a simple standard for once. And there is a GitHub repository where you can look at the current state of development. So you heard Ige talk about the thing description, which is a format to describe a single thing. And SDF is a format to describe a class of things, so things with certain common characteristics. And of course, that's not that much different. So some of the things you saw on Ege's slide will come up on my slides again. And of course, it's all the same people who are doing this work. So there's a lot of cross-pollination here, and we are trying to not emphasize the competition here, but actually the way how these things can work together. So IoT things don't have data, so it's a bit weird to talk about common data models for IoT things. Things have interactions with their peers, and I'm going to use the word clients here. That's not a OneDM term because it sounds like client server, and we are going beyond that. But bear with me for these slides that I call the guys who are not the things clients. So those things offer interactions that can be done, and we call them affordances. You saw on Ege's slides, and it's kind of popular to group affordances into interaction patterns. So right now we are talking about property, action, and event patterns, and I'm going to go into those later. And of course, those interactions actually do input and output data, and that's where the real data model part of the SDF model come in. But you have to have the other parts, the interaction part, so that these data models actually make sense in context. So let's talk about those interaction patterns. Property, action, and event. And actually, most protocol environments have something like that. And because people may be familiar with REST, I put in a column here that has the REST name of that interaction pattern. And I also have a column that talks about the initiative. So who's actually starting this interaction. And the final two columns of the table show what kind of data is actually processed while performing this interaction. And typically you can talk about input data and output data. So a property is like something that is like a REST GET affordance. It can be initiated by a client, and it gives you some output data. But there are also writable properties, which are properties that also allow a put interaction, so that there are two different interactions provided by the same affordance here, if it's writable. And of course, the idea is that a property put or set actually changes something that is used by the thing to do its work, like a temperature set point or color or something like that. The second group of interaction is the action, which is pretty much a remote procedure call in the view of many people. In REST, we have the post primitive for that. The initiative, again, is with the client, and there is input data and output data. And these input and output data are different, because it's not just setting a proxy here, a property here. It might be something like starting a process, making a coffee or something like that. So the output data, of course, on the physical side will be the coffee, but on the side that we model here will be the fact that the coffee is done and maybe some additional information about it. And finally, there is the event, which is something that is not really supported very well by REST. So that there are various ways of supporting event-style data in various REST environments. The point here is that the initiative is actually with a thing. So in the REST world, that would be the server, and servers normally don't generate initiative. But the whole point is that the event also has some data, which I call output data here, and that is the third pattern. So let's talk about those patterns in a little bit more detail. So the action pattern is sometimes in some ecosystems, it's the only thing you have. You can send a command to something and you get a response, and whether that was a property right or an actual action in our sense here, that's not modeled. So here we do distinguish properties, which are just data that can be set atomically, and actions which do something, create an output that is the result of an operation, and actually may take some time to do. So an action may have a client initiative to initiate it, but then it may only result in data later. So it's a little bit different from a property which always happens instantly. So this is the only pattern we have where we have two different data models that go into it. So I talked about properties already a little bit. Let me just point out that SDF also has an observable property, like the thing description picture you just saw from Egger. And that's pretty interesting, because with an observable property, the initial initiative, again, is with the client. But from then on, it's the thing that tells you that there are updates to this property. And you can see this is actually not much different from an event. So it's not quite clear how where the boundary between these two is. So let's look at the event. That's maybe the least well-defined interaction pattern. But from a data modeling point of view, it's actually easier. I mean, it's not different from a property at all. It generates some output. And from the data modeling point of view, it doesn't make a big difference whether the client requests it or comes on its own by itself. But there are still semantic differences that we are not modeling right now. Events might be like observable properties, just status updates, so the temperature changes, so you get an event that the temperature has changed. Or they may actually be more heavyweight occurrences, where every single one of them is precious. So you might model the insertion of a coin in a device as an event. And then, of course, you need to model the fact that you cannot lose these events. So there we have a little bit of openness in the specification, but in the end, we define the output data, and that's what we focus on in the data model work for now. So let's talk about data. Yes.
We have Ege in the queue. Is it okay to take questions, comments now?
Yeah, so we also had this discussion regarding properties that are observable and events. And for now, like the way we sort of like not really solve, but we first of all leave it to the developer, but as a feeling, so to say, is that generally the events are things that you like need some sort of a more configuration to set up. So like some sort of like subscription payload that you send and like set up some sort of a delivery mechanism. And then whereas in properties, then you would need to add more like sort of information into how we would set up these things. So we leave this kind of heavy event streaming protocols to the event affordances. And also for observable properties, we sort of say that it reports only the changes to the properties. So if you want to, let's say, send every second the position of a robot, whether it changes its position or not, we would like imagine it's like an event stream. So that was sort of like a discussion we also had at some point, and I think it might be also useful for you.
Okay, thank you. So yeah, it's interesting because properties actually, knowing that you have recent data about the property is different from not knowing anything. So I think you are missing some information in that modeling. But let's not compare the things. Let me try to explain what's there at the moment. And again, the point is that in the end, we come out at a data definition, and the data definition works by saying what kind of data should be there. So we have, of course, we all know lots of data definition or schema languages. And data definitions can, if they are simple, be just put inline in an affordance definition, or you can put them separately into the specification because it's used by several affordances and you don't want to repeat it everywhere. So right now, the data definitions in SDF can use a subset of the JSON schema org terms they have in the validation language, and they also can use some SDF-specific terms. So for instance, you can say that the data has a particular media type or content format, as we call it, or you can say that data are nullable, have certain scale limits, and so on. So that probably requires a little bit of a longer-term discussion how we actually evolve these data format elements. Right now, this is pretty much based on what we found we could immediately use. I'm saying this from a academic point of view, from a practical point of view. We have a pretty good set of terms right now, so we can do work. But it's not really a set of terms where you would say, oh yeah, obviously that's the way data definition should be shaped. So I expect some evolution there. So from these components, from the data definitions, from the affordances that actually make use of these data definitions, we can build objects. So objects are just combinations of affordances. So it just makes sense to have several affordances defined together. So if you have a thermostat, you might want to have a writable property for the set point, but you might also want to be able to find out what is the current temperature, or is the heating on, or things like that. So there are several interaction affordances held by the same object. And these objects, in turn, can be combined into things. So the assumption is that it makes sense to reuse object definitions in things, and I think that's something that many SDOs have. And things actually can reuse things. And I've put a little green thing here, insert magic, because we are still discussing how exactly to model a thing that's actually composed of multiple things of the same class. So if you have a smart outlet that might have a fuse, which you can read whether it's open or still working, you might have a switch, you might have several outlets which might have properties like current flow and so on. And the way these objects are put together to a thing, that's currently still being discussed. But the point here is that we can build up a little library of objects that we actually can use to build things. And then in turn, ODM products are combinations of things that are not harmonized, but that what describes the specific products. You can find out what SDF definitions govern the workings of that product. So I've talked about the specification in abstract terms. The concrete specification is just represented in JSON, because that is the best way to actually handle the specification with tools. And these JSON documents are linked together with JSON pointers. We use JSON pointers also to point into specific documents, also for internal references in such a document. And the fact that you can point to things means, of course, that you can reuse specifications from other elements, from other specifications. And one thing that might happen soon is that we define something like a basic call set that every specification can reference. So these would be common reusable definitions. So SDF, of course, is something that needs to be specified. And since SDF specifications are JSON documents, we can again use a data definition language to define how these JSON documents look like, and that's currently using the JSON schema org terminology. So it's really important to be careful not to confuse the use of selected JSON schema org terms within SDF with the way we describe the syntax of the format. In addition to the syntax, of course, we need semantics, and that's currently just a text file and actually a markdown file to make it easy to collaborate on that. And there's also a nascent best practices document that will define not so normative parts, so people know how to best use this. So, of course, in reality, when you develop something, there's also a lot of knowledge about the semantics and the way things work together in the tooling that is being used. And it's really useful to look at the tooling that is used by the One Data Model playground. There's a little continuous integration system there that calls a program that looks at every SDF specification, actually using two different JSON schema org style specifications, and also looks at other things like file names and so on. The next step, okay, I forgot I have one more slide. So right now we are in a situation that we think the specification is stable enough to submit data models. So we reached that stage in Stockholm in October last year. So several hundred data models are now collected at the playground. And more importantly, the ecosystem SDOs have started developing tools to convert their corpus to SDF. So many of the examples in the playground are from these tools. Right now, the OCF specs are missing because there's still a little bit of work to do to make them work again, but I expect a few more will be in there quickly. And the use of tools is really important to make sure that we have good coverage without creating enormous amounts of work. So we have these data models coming up, and we are learning a lot about what data models actually need. The specification itself also needs some cleanup. So in particular, the natural language part of it needs an editorial round. And we are looking at a 4-day online conference in the first weeks of May to actually do this kind of work. So originally we planned a face-to-face. That's not going to happen. And in order to get the work done, we will have 2-hour slots distributed over 4 days. So we make some progress. And the whole thing, I think, should be completed by the end of May. Last slide. So what are we going to do next? I said we're going to fix the language and so on. But I think the really interesting work is now to get tools done on the model consuming side. So we know how to produce these models, but that doesn't give us a lot of certainty that these models are actually useful. So we actually have to do work now building tools that consume these models and do something useful based on the information extracted from those models. So this is one of the points of the Wishy hackathon. And I think one of the fun parts will be seeing how SDF and W3 what thing descriptions can be combined to make this useful. So thing descriptions have all these things like protocol bindings and so on that SDF actually doesn't have. So it makes a lot of sense to work with those together. Yeah, so a few things need to be solved to get something like an SDF 1.0, which would be an output of that liaison group. We can use those playground definitions to serve as a corpus in solving these issues. And one of the interesting aspects of having all these models in one place is that if we make a non-backwards compatible change to SDF, we can just go over all these definitions with a tool and change those definitions automatically. So we don't have to be quite as afraid of doing non-backwards compatible changes. So for instance, we had a rare spelling of the word writable already in a previous version, and we have fixed that, and we could easily fix that because we could just run it over all these models. So this is something that will be done in the spring, early summer this year. And then, of course, the next question is how do we turn SDF into a real world specification? So we probably want to find a venue for standardization, and typically the IETF comes up as a potential venue there, and those are discussions that now need to be held to find out whether the IETF is the right place to do this and actually wants to do this. Questions?
Hi, Carsten. This is Mohit. So I think this all makes sense. Who do you think would be doing the like if I am part of this ecosystem, what's the motivation for me to like publish this in SDF? And then who would be then doing the proxies?
Well, the motivation for publishing the ecosystem specific specifications in SDF is that you want other people who are rounding out their ecosystems with specifications for the things that you already have stay compatible to you. So you are kind of the opinion leader for this particular kind of thing. I think that there's tangible value for that, and one of the reasons why the ecosystem people are so interested in making their specifications available quickly. So how do you actually work in this space? Well, as I said, right now it's a liaison group, so you have to be affiliated with one of the ecosystems to actually join the actual OneDM meetings. But since the work is happening in the open, you can just send a pull request to the playground and submit things, and you can be sure that other people will be looking at that and give you feedback.
As I understand, that doesn't answer the question about who is doing the proxies yet. Sorry, Christian.
Well, again, the people who are working in the specific ecosystems and are trying to make their specifications maximally useful. These are also interested in doing the proxies. First of all, of course, to test out the SDF specification itself. Do we have everything in there to build a proxy? But also to validate that the ecosystem-specific side actually can be done and nothing is missing there. Does that answer your question now?
Yes.
Yeah. Thanks.
I would kind of have expected an answer that says that one proxy would do this all from the specifications, but of course this won't cover the protocol specifics.
Well, you have to have protocol bindings for the specific ecosystem, so it's quite different to switch on a Zigbee light than to do it using CoAP. So of course there are those proxies already. So IKEA sells a box that speaks CoAP on one end and speaks Zigbee on the other. I'm sure that the people who build these proxies will also enter the work at some point. But at the moment, really, the push is from the people who have all these hundreds of data models and want to make sure they work globally in the world of IoT and not just within the ecosystem.
What we're doing for the demo is we're using we're planning to use the T2TRG Web of Things implementation in Eclipse Foundation called ThingWeb Node Watt, which has protocol bindings protocols that we're using already. So we're basically planning to use the SDF model with creating a description for each of the proxy that has its protocol binding that describes that protocol, and then sort of do the work inside Node Watt, if you will, to do the actual proxy conversion by property or whatever we need to do.
Good. Thank you, everyone. It's very good discussions, but I'm afraid we're running a bit short on time. So maybe Lars can prepare to present next. And for everyone who's more interested on this particular topic, I recommend you join one of our upcoming Wishy OneDM meetings. So even if the OneDM, let's say, core work is happening within the liaison group, that is not open for everyone, the work we do in the Wishy group is open for everyone to join, just like any other things in our research group meetings. So I recommend you join those and discuss this in more detail. Carsten, any closing notes before we move to Lars's presentation?
No, that's pretty much the closing note I would have made as well. So I think the research group is a good neutral ground to do work in this space.